Okay, so we can club the two sequences. So accordingly, what we'll do is we'll first consider the first sequence x1 of n, find out its DFT, then pick the second sequence x2 of n, find its DFT, and combine the two results. So let's start with x1 of n. If x1 of n is cos times pi by 4 times n. Now, I want you people, what you people must do is vary the value of n as what? 0, 1, 2, and 3. Since it is 4-point DFT, I exactly want 4 values, okay, of this input signal. So for the first time, when the value of n is 0, cos 0 would be equal to 1. Cos 0 would be equal to 1. So the first value of my input sequence is 1. Similarly, when the value of n is equal to 1, what is cos pi by 4? What is cos pi by 4, students? Is it 0.7071?
Yes,
Everybody must
ma'am.
respond yes.
Yes, ma'am.
Next, when the value of n is equal to 2, becomes what? Cos pi by 2, cos 90 is 0. So the third term is 0. And when the value of n is 3, cos 3 pi by 4 turns out to be a value of 0.7071. So these are the 4 sample values for the given input sequence x1 of n, Okay, so accordingly, let's start to find its DFT. The equation goes like this. Therefore, x1 of k is nothing but summation small n varying from 0 to n minus 1, x1 of n multiplied by its twiddle factor wn raised to the power of n into k. There's no need to wait for me. I expect answers from your side. You people know the procedure, just proceed. No need to wait for me. In this case, since the value of capital N is 4, n minus 1 is 3, x1 of n, w, the value of capital N is 4 times of n into k, Okay, so may know now what I want you people to do is at the beginning, what is the value of w4 to the power of 0 is what? 1 obviously. What is w4 to the power of 1? I want the answer. I want the answer for w4 to the power of 2. What is the answer?
Minus
And
j.
what is w4 to the power of 1? Is it minus j?
Yes, ma'am.
Yes, very much right. Good. What is w4 to the power of 2? Everybody must participate, not just 1 or 2. What is w4 to the power of 2? Check it out and give me the answer. Similarly, yeah, w4 to the power of 2 turns out to be minus 1. Am I right? Check it.
Yes, ma'am.
Yeah, it's minus 1. Accordingly, what is w4 to the power of 3?
J.
Yes?
J.
Plus j. Fine. Done, ma. So we are done with all the values. Now we can just want to expand the series, expand the summation series. Therefore, x1 of k turns out to be x1 of 0 into w4 to the power of 0 plus x1 of 1 into w4 to the power of 1 plus x1 of 2 into w4 to the power of 2 plus x1 of 3 into w4 to the power of 3. You're having all the values. Okay, do not expect me to substitute the values. Substitute it and give me the answer. Is it clear? See here, x1 of 0, x1 of 1, x1 of 2, and x1 of 3. All the 4 values are there over here. Substitute it and give me the answer. For the next few seconds, I want the answer. x1 of 0 was 1, w1 of 0 is also 1, done. x1 of 1 was 0.7071, w4 to the power of 1 was minus j. The value of x1 of 2 was 0, neglected. The value of x1 of 3 was minus 0.7071 and the value of W4 to the power of 3 was equal to plus J, So accordingly, the answer is what? It is what? 1. Then the students are pretty slow.
Minus 1.414.
Yes, 1 minus J times 1.414. See, before I could have done x1 of k, sorry, 1 second. This is not x1 of k. This is x1 of 1. Okay. Since the value of k we've chosen is 1, please note that this is x1 of 1. Similarly, what you must do now? You have to find x1 of 2, x1 of 3, okay, and so on. Okay, now listen 1 second. Listen. I'm sorry. Okay, this is the value of x1 of 1. I think prior to this, we should have done what? x1 of 0. Assume the value of k. Okay, no issues. This is the value of x1 of 1. Absolutely right. Okay, we'll do for the other values also. x1 of 1. This is the answer. Please note that since the value of k also runs from, 0 to, what is that? 0 to 3, n minus 1. So we found x1 of 1. Initially, we should have found x1 of 0. Okay. I think you people can do it. What is x1 of 0? Okay. Please note that all these terms, W4 to the power of 0, W4 to the power of 1, 2, and 3, everything turns out to be 1 only. Okay. So it is x1 of 0 into W4 to the power of 0 plus x1 of 1 into W4 to the power of 0. Again, it will be x1 of 2 into W4 to the power of 0. Lastly is x1 of 3 into W4 to the power of 0. Okay. So accordingly, substitute the values. X1 of 0, or this would be 1, and this, or x1 of 1 is 0.7071. Okay, the value is again 1. Next is 0. The next value is minus 0.7071 into the value of 1. Accordingly, the value of x1 of 0 turns out to be 1. This is the first value which we are required to do it. We had omitted this. Okay. So we have done with x1 of 0 and x1 of 1. You people must calculate and give me the answer for x1 of 2 and x1 of 3. Is it clear, students? Any doubt in any of the steps? Kindly let me know. So accordingly, next is what? For the value of k is equal to 2, what I must find? x1 of 2. x1 of 2 would be equal to, what is that? x1 of 0. x1 of 0 into W4 to the power of 0. Then what? x1 of 1 into W4 to the power of 2 plus x1 of 2 into W4 to the power of 4. Next is what? x1 of 3 into W4 to the power of 6. W4 to the power of 6.
Ma'am, excuse
Yes.
me.
Yes.
Ma'am, can you teach me that W to the power 4, W4 to the power 0, W4 to the power 1, that's the value, how to find out that?
Okay. See, generally, okay, yes, I'll just say. I think you're absolutely the first class. See, generally, Wn is e to the power of minus j 2 pi by n. Yeah. This is Twiddle factor. If you're finding for, in our case, since the value of n is 4, W4 would be equal to e power minus j 2 pi by 4. Is it clear? So this is the general value in our case. If you're finding the value of W, say for example, W4 to the power of 0, it's what? E power minus j 2 pi by 4 raised to the power of 0. E to the power of 0 is always equal to what? 1. Similarly, W4 to the power of 1 is what? Pull back a W4 value is what? e power minus j 2 pi by 4 raised to the power of 1 is what? E power minus j 2 pi by 4 is what? E power minus j pi by 2. This is nothing but what? Cos pi by 2 minus j times sine pi by 2. Is it clear? Cos pi by 2 is what, yaar? 0 minus j sine pi by 2 is 1. Hence the value is minus 0. Is it clear? Similarly, you must go for W4 to the power of 2 is what? E power minus j 2 pi by 4 raised to the power of 2. Okay, it is equal to what? E power minus j pi. E power minus j pi is what? Cos pi minus j times sine pi. Sine pi is 0, cos pi is minus 1. Similarly, you can find what? Find the value of W4 to the power of 3 is what? E power minus j 2 pi by 4 multiplied by 3. It's nothing but e power minus j. It is what? 3 pi by 2 is cos 3 pi by 2 minus j times sine 3 pi by 2. I think this turns out to be the value of plus j, 0. This turns out to be minus 1. So minus of minus j turns out to be plus j. Is it clear? I think this has been taught in the earlier classes, madam. I think you were absent, or at least I'm
Thank
not
you, ma'am.
seeing the
Yeah,
recorded
I was
videos. Okay. Kindly, okay, come prepare for the previous class syllabus bar. Okay. So that we can save some time. Is it clear now?
Yes, ma'am. Thank
Okay,
you so
fine.
much.
Okay, students, are you done with x1 of 2? What is the answer for x1 of 2?
1.
1. Exactly right. The answer is right. X1 of 2. I mean, you people must do it. You can't expect me everything to be done on this board. Okay, yes. Similarly, I want the answer for x1 of 3.
1 plus 1.414.
Yes, exactly right. 1 plus j times 1.414. Okay. Now do one thing after this, okay, just write off the values. Therefore, x1 of k, summarize the answer for x1 of k. x1 of 0 was 1. x1 of 1 was 1 minus j times 1.414. x2 of x1 of 2 was 1, and x1 of 3 is 1 plus j times 1.414. Summarize your answer always. Don't give opportunity for the examiner to search your answer. Always, whatever intermediate answer you get, summarize it and put it in a box. Done. Now let's begin with the second sequence, x2 of n. What is x2 of n? Equal to sine times pi by 4 times n. Okay. Again, I want you people to vary the value of n from 0 to 3 and give me the first 4 sample values. When the value of n is 0, sine 0 is 0. When the value of n is 1, sine pi by 4 is once again 0.7071. When the value of n is 2, sine pi by 2 is 1. When the value of n is 3 pi by 4, again I think the answer, the term is 0.7071. Check it out. Are the 4 sample values right?
Yes, ma'am.
Yes.
Yes, ma'am.
Now do one thing. What we'll do now for this second DFT, let's not go by the formula. Let's go by that, what is that, as a linear transformation here. Okay. We'll use that matrix method so that we'll be able to do it quickly. At the same time, you people will also be learning the other method also. So what we want is, we want the value of x2 of 0. Okay, x2 of 0. Go by that the matrix method. x2 of 1, x2 of 2, x2 of 3 would be equal to is what? Write the twiddle factor matrix. Write the twiddle factor matrix. See, by this time, no, for 4 cross 4 twiddle factor matrix, you people should be acquainted with the values here. You people should be able to give the values directly. Okay, that should be your, what's that, preparedness. The first row will be all 1. The first column will be all 1. Remember this. Okay. then this term is minus j, this term is minus 1, and this term is j. Because I've done the problem n number of times, this whole matrix is there in my mind, so I'm able to do it quickly. Okay, this minus 1, this term is also 1, and this is minus 1. This turns out to be j, this turns out to be minus 1, and this turns out to be minus j. Okay, and your small x1 of values, it's what? 0, 0.7071, 1, and 0.7071. I hope all of you are very good at matrix multiplication. I want the values here. x2 of 0, x2 of 1, x2 of 2, and x2 of 3. Okay, you people do it and give me the values. I've given you the matrix. All you must do is matrix multiplication. First row into first column, second row into first column, third row into first column, and the fourth row into first column. Yes. Any doubt in this above step? No voice from the other end.
No doubts, ma'am.
Yeah. Please do it quickly then. See, in fact, this method is much more easier and quicker. We're using the DFT as a linear transformation, and we are using the formula as capital X of n is equal to Wn into Xn. It's a faster way of computing DFT. Always when you're doing such kind of numericals, okay, the whole class, there should be some kind of healthy competition here. As we will do it fast and we will give out the answer. With that pace, people must do. At the same time, must do it correctly also. Okay? Yeah. Anyone was done for x2 of 0? First row into first column here is x2 of 0.
2.4142.
Yes, it's exactly right. The first x2 value is x of 0 is 2.414. Absolutely right. Yes. Now you can proceed for x2 of 1.
Ma'am, minus 1 minus 1.414j.
Yes, exactly right. The girl has done it quickly. Minus 1. The next term, x2 of 2, is minus 0.414. The last term is minus 1 here. Am I right?
Yes, ma'am.
Somebody
Yes,
told
ma'am.
some j, somebody told some j. No, yeah. These are the values of x2 of k. Okay. Now, since we have found now x1 of k individually and x2 of k individually, now what is that? But the property of linearity, what is that? What happened to it? Oh yeah, therefore is that x of k is equal to what? x1 of k plus x2 of k. What you must do? x1 of 0 plus x2 of 0, x1 of 1 plus x2 of 1. Similarly, the next two values, you must add up. Okay, add up the corresponding sample values. Accordingly, x of k would be what? x1 of 0 was 1, I think, right? This is 2.414. If you could add up, I end up in 3.414. Similarly, x1 of 1 was what? 1 minus j, 1.414. This is what? Minus 1. So I end up in the answer as minus 1.414j. The value of x of 2 would be 1 plus 0.1 minus 0.414. It turns out to be 0.586. Cross check, I might be wrong. The value of x of 3 is 1 plus 4.141j minus 1. It turns out to be 1.414j. Is it clear? What you must do is add the corresponding sample values. x1 of 0 plus x2 of 0 gives me this. x1 of 1 plus x2 of 1 gives me this. x1 of 3 plus x2 of 3 will give the next values and so on. 0th sample, first sample, second sample, and third sample. Yes, students, done everybody?
Yes, ma'am.
Yes, ma'am.
Shall we move to the next problem of the day? All of you?
Yes, ma'am.
Yes,
Okay,
ma'am.
for the very few,
Yes, ma'am.
very few students, nobody else will reply. Yeah. The next problem goes like this. Take down quickly. Compute the DFT of the sequence given below. Compute the DFT of the sequence given below using linearity property. Using linearity property. The given sequence is cos HAN, cos hyperbolic value of AN, where the value of small n range from 0 to n minus 1. N minus 1. Compute the DFT of a given sequence x of n using what? Linearity property. Using linearity property. Yeah. The value of n runs from 0 to n minus 1. Yes, students. Finish copying the problem.
Yes, ma'am.
Yeah. And what is this? We have to apply linearity property. Is that in a given sequence x of n, how many sequences have been defined? I've just got a single sequence, right? Cos HAN. Yes or no?
Yes, ma'am.
Then where is the point in applying linearity property? Only if in the earlier sequence I had got two sequences, cosine and sine. So I found out their individual, values, and I did it. What about the present context? I've just got a single sequence, right? Cos hyperbolic value of n. Then where is the point in applying the linearity property? Okay, are you guys able to listen to me, students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
What is it? Do you think that we have to apply linearity property here? Yes or no?
Yes, ma'am.
Why?
Formula of
We have to apply
Yeah,
formula.
that's it. Okay. So what you must do is expand this value of cos HAN using the Euler's formula. Accordingly, x of n turns out to be e to the power of an plus e to the power of minus an divided by 2. Okay. So I'll not solve this problem completely. I'll leave it halfway. I'll just give you the steps. You people must proceed. So therefore, DFT of the given sequence x of n is nothing but what? 1 by 2 times DFT of e to the power of an plus 1 by 2 times DFT of e to the power of minus an. Okay. So find out the individual DFTs of this sequence and this sequence. Then you should submit the answer. You will get the answer. Will you guys do it for yourself or you want me to do it now? Some kind of reply from the other side. The problem with the class is they don't talk. Will you guys try this part in the house?
Yes, ma'am. We'll try.
We'll try. Okay. I'll be also sharing the solution also. It's pretty simple. Take the sequence individually, find its DFT. Take the sequence individually, find its DFT. I'll be also sharing the solution. In case still you don't follow, get back to me afterwards. Is it clear to all of you? The boys there?
Yes,
The
ma'am.
boys, yes, fine. Leave around some 3/4 page of space, around 1 page of space, and let's continue with the problem number 3. And see to it that you people will do the sum today itself. Yeah, sum number 3. Okay, yeah. Take down the problem, sum number 3. See, if there are 2 or 3 students who find it tough, no, madam, do it on the board, let me know. Based on the opinion of whoever is speaking, I'm going further. If anybody has got an issue, you must raise your voice. Yeah. Find the 4-point DFT. Find the 4-point DFT of the given sequence x of n. X of n is equal to what? 1, minus 1, 1, minus 1. You are required to find the DFT of this sequence. Okay, and Also, the problem continues. Also using time shift property, find DFT of the sequence, find DFT of the sequence, y of n is nothing but x of n minus 2 modulo 4. So first we are required to find what the 4-point DFT of the given sequence x of n, of a sequence x of n. That is the first half of the problem. Then we are required to apply the time shifting property, and find the value of the sequence y of n, which is nothing but the time shifted version of the sequence x of n, So let's begin with the solution. We'll just do the first part. Part 1 we'll do. Okay, part 1 solution we'll do. Again, see, best is, see, in the exam, until and unless the examiner specify which method should be used to compute the DFT. Okay, if he says formula method, go for formula method. If he says use linear transformation method, use linear transformation method. If the examiner doesn't specify, the quick way to find the DFT is to always use this linear transformation method. Okay, that's going to save a lot of your time. So accordingly, again, here also I'll be using the same linear transformation method to find its DFT. Probably this is the last somewhere I'll be using this method here. Okay, next time I'll just say you people must do and give me the answer. You must do it. Okay, today for the first time I'm doing it, so I am doing this step on the board. Next time you should do it for yourself, and see to that this matrix elements are stored inside your mind permanently, because you'll be using this at n number of places. So this matrix, W4 matrix elements, should be there inside your mind permanently. The value of xn elements are 1, minus 1, 1, and minus 1. So solve this and give me the value of the elements x of k, x of 0, x of 1, x of 2, and x of 3. Where the students disappeared, is it? What's the value of x of 0?
0.
Fine. See, if you're doing it fast, you'll be improving your speed. It's not that I'm hurrying you up, okay? In the exam, you can save more amount of time to go for question number, what is that? The next question also. You can also always answer extra question. Okay, x of 0 is 0. X of 1?
0.
Exactly right. X of 2?
4.
X of 3?
1 minus j.
No, yaar, I'm sorry, it's wrong. X of 3?
2.
Yes?
2.
Wrong. X of 3?
0.
It's 0, yes, absolutely right. You must not go wrong, please do it correctly. It is 0, 0, 4, 0. Hey, what about it? There are no boys in this class? Always only girls must give the answer, is it? I expect the boys also to participate equals. Don't think that's not your job, yaar. Yeah, done. So this is the first part. Next, what is that? We must go for part 2 solution. What is given is, they've asked me to find what? They've asked me to find the DFT of the sequence y of n. What is y of n? The time shifted version of the sequence x of n. Is what? X of n minus 2 modulo 4. Please note that this is circular shift. The minute you get index modulo 4, It indicates what? Circular shift, circular shift. So what is y of k basically? Y of k is nothing but what? DFT of y of n, which is nothing but what? DFT of x of n minus 2 modulo 4. Now I want one of the boy in the class to state the time shifting property. Quickly. See, if I meant to say time shifting, see when you could observe the sequence, x of n minus 2 modulus 4, the shifting is being done in the time domain. Please note that we have learned two time shifting properties, shifting in time domain and shifting in frequency domain. In the present context, the time domain sequence has been shifted. So I want one of the boy to state the time shifting property. Yes, the time shifting property statement goes like this. X of n minus L modulo n is said to form an n-point DFT pair with what is called as x of k, and when I'm going to time shift, the circular time shift the sequence in the time domain, its equivalent DFT has to be multiplied by the factor Wn raised to the power of L into K. Shifting in time domain results in complex multiplication in frequency domain. Whenever I stress the statements, you must note it here. You can't simply copy it. Okay. So in my present context, x of what I want, x of n minus 2, index 4. So accordingly, it's what? X of n minus, what is the value of L? The value of L is 2. And what is the value of capital N? Index modulo index 4 is said to form what? An n-point DFT pair with W. The value of capital N is 4. The value of L is what? The value of L is 2. 2 times of K into X of K. Please note that we are finding Y of K without applying the GFT formula, just by applying the property statement. So accordingly, this turns out to be, what is W for expansion, yeah? E power minus j 2 pi by n. The value of n is 4. What is the power left out to us? It is 2 into k multiplied by x of k as it is. Multiplied by x of k as it is. So 2 2s are 4 and 4 will get cancels. I end up in what is called as, I end up in e to the power of minus j times pi times k into x of k. This is the value of x of n minus 2 modulo index 4. This is nothing but what? This is nothing but what? My DFT of the sequence y of n. So accordingly, y of k is, please note that the value of e power minus j pi, keep in mind, the value of e power, please note that the value of e power minus j pi is always equal to minus 1, is always equal to minus 1. Check it out. This is nothing but what? Minus 1 raised to the power of k into x of k. Into x of k. What all I want? What is the range of k? K will run from 0 to n minus 1. It's what? 0 to 3. So accordingly, what is y of 0? Y of 0 is minus 1 raised to the power of 0. What was the value of x of 0? It is substituted, give the answer. Similarly, y of 1 is minus 1. The value of k is 1 into x of 1, whatever is the answer. Accordingly, y of 2 is nothing but minus 1, the power of 2 into x of 2. The answer is, accordingly, lastly, y of 3 is minus 1 to the power of 3. Substitute the value of x of 3 and the answer. Yes. What is y of 0?
0.
0, ma'am.
Okay, 1 second. 1 second. Okay, for y of k is equal, yeah, y of 0 is 0. What is y of 1?
0.
0.
Yes, fine. What is y of 2? The boys. Y of 2. Yes, say girls will always prompt that. What is y of 2?
4.
4.
Yes, exactly right. It's 4. What is y of 3?
0.
0.
So accordingly, the answer is 0, comma 0, comma 4, comma 0. See, whenever you're going to describe a new sequence, please mark the 0th indexing by this arrow mark, because especially when we are doing the time shifting property, sometimes the 0th indexing will change. So please always mark the 0th indexing by this particular arrow mark. Is it clear now? So this is the solution of the given problem. Any doubts? Any doubts to anyone? No response. Can I hear any of the boys' voice or there? The boys?
Yes, ma'am.
ಪಾಠ ಕೇಳ್ತಾ ಇದೀರಪ್ಪ ಎಲ್ಲ ಹುಡುಗರು?
Yes, ma'am.
ಮಾತಾಡೋದು ಬೇರೆಯವರೆಲ್ಲ ಎಲ್ರಿ? Where is Elvin? Elvin is there?
Yes, ma'am.
I don't know. Come on here, I don't know how you people do really respond in the actual class also. Fine. Shall we move to the next problem? Sum number 4, students.
Yes, ma'am.
Yes, ma'am.
Fine. Take down so the problem is quite big. Okay, I cannot write the whole sentence. I'll just write the sequence. Please take down the statement. Shall I start dictating? Yes. Probably
Yes,
if
ma'am.
anybody is still copying, I need to give some time for them. That's all the intention is. Yeah. Suppose, take down the problem statement. Suppose x of n is a sequence. Suppose x of n is a sequence defined on 0 to 7. Defined on 0 to 7 means the indexing n will run from 0 to 7, small n. Okay, that's what they mean. Suppose x of n is a sequence defined on 0 to 7. 0 to 7 only, 0 to 7 only, as x of n, take down this 0, 1, 2, 3, 4, 5, 6, 7. These are the sample values of x of n. Illustrate x of n minus 2 modulo 8. First question. Second question is, if DFT of x of n is x of k, then what is the DFT of? Then what is the DFT of x of n minus 2 modulo 8? Yes. This is a problem statement. Take it down so that we can move further. We'll go for the solution. I can't, in fact, literally see you people here. If you're done, you should say, yes, ma'am, next step. Yes, should we proceed now? Yeah. First, what we'll do is, we'll just pick back our original sequence. X of n is what? 0, 1, 2, 3, 4, 5, 6, 7. See, as I told you earlier, whenever any question is given in the exam based on time shifting property, it is a duty of the examiner to denote the 0th sample. In case the sequence has been not defined, so in this case, they have not defined the 0th sample, okay, they have not indicated, then by default, the first sample is always the 0th sample. We assume that the first sample always corresponds to the 0th sample. So what I'll do is, I'll just represent this on a circular scale, This looks like this, okay? If this is your x of n, please note that on a circular scale, I've assumed that marking the values in the anti-clockwise direction has to be the positive direction. So accordingly, this is the first value 0, next value is 1, next value is 2, then it is what? 3, 3, next it is 4, next it is 5, then it is 6, then it is 7, then it is 7. Okay, this is a given sequence x of n. Now what I must illustrate? I must illustrate the time shifting property. The circle shape is very bad, neglected. X of n minus 2. What is that? Modulo 8. The minute I say x of n minus 2 modulo 8 was n minus 2, the value of L is 2 means the sample values on the circle should be shifted by an amount of 2 units in the anti-clockwise direction. I'll repeat once again. Since the value of L is plus 2 over here, the value of L is plus 2 over here, you are required to shift the sample values by a value of 2 in the anti-clockwise direction. So what happens? Instead of starting from 0 over here, shift 1, shift 2, what I must do? Start from here. This is 0, this would be 1, this would be 2, this would be 3, this would be 4, and this would be 5, and this is 6, and this is 7. This is 7. Is it clear? This is how you represent it. But sometimes the examiner might say, illustrate the same shift also on the linear scale. Also on the linear scale. Then how will I do it? This is what? Illustration on the circular scale. If they say illustrate it on a linear scale, it goes something like this. It goes something like this. Okay. First, let me mark the first sequence. Now, say for example, this is your x of n, okay, and this is your indexing n. This is what the first value is what? 0. Then it is what? Say for example 1. Then say it is 2. Then say it is 3. I can't write it very neatly. Please adjust 4. And say if this is 5, say this is 6, say this is 7, say this is 7. Okay, this is what? The representation of a given sequence x of n on a linear scale, For the same thing, what I want, the representation where? Representation, okay, for my second sequence. What is the second sequence now? X of n minus 2 modulo 8. X of n minus 2 modulo 8. What I must do here? I must not start from indexing 0. Instead, what I must do? Start from indexing 2, the first sample. Somewhere over here, I must start. Somewhere over, one second, I must start from over here. This is what? 0. Then it is what? 1. Then it is what? You people, please write onto scale. Then it is what? 3. Then it is what? 4. Then it is what? 5. Please note that unlike in linear shift, I can't go, for example, say this is my 0 sample, first, second, third, fourth, fifth, sixth, and 7. Please note that this is again what? This is your 0 sample, first sample, second, third, fourth, fifth, sixth, and 7. See, please note that if it was a linear shift, the next sample 6 would have come over here, and the next sample 7 would have come over here if it was a linear shift. But since this is a circular shift, the next sample will not come at the 8th position, but in fact, where it goes, it has to go back to the 0th position over here. Over here, my indexing 0 will come, and over here, my sample 7 will come. Is it clear? It is 0, 1, 2, 3, 4, 5. It is circular shift. So what I must do? Once again, the sequence has to repeat. It's what? Back 6 here, back 7 here. If it was a linear shift, the sample number 6 would have come where? The sample number 6 would have come at this position 8, and the next sample would have come at position number 9. For it was a linear shift. For it is a circular shift, the samples will come over here and over here. Is it clear? The representation of the given sequence both on the linear scale I've shown and also on the circular scale. This is the illustration, the answer for part A. Shall we go to part B? Any doubt?
No, ma'am.
No. Yeah, we'll go for part B. We'll go for part B. I think part B you people must do and give me the answer. Yeah, now you know how to do part B. What is your part B? What I must find? I must find the DFT of, what is that? X of the same time shifted sequence, x of n minus 2 modulo 8. This is nothing but what? This nothing but forms what, yeah? It nothing but forms an endpoint DFT. What I must do? Whenever there is a time shift, whenever there is a shift in the time domain, what happens? The equivalent frequency domain has to be multiplied by its respective complex conjugate term. That's what? Wn to the power of Lk. So accordingly, what happens here? X of DFT of x of n minus 2 modulo 8 is nothing but forming an what? An endpoint DFT pair with what is Wn here? W to the power of n is what? 8. The value of L is 2. 2 times k into x of k. So this is nothing but what? This is nothing but, substitute the value of W8 is what? E power minus j 2 pi by 8 times 2 times k as it is into x of k. Into x of k. 2 2s are 4. 4 and 8. Okay, remove that. I end up in e power minus j pi by 2 times k into x of k. Please note that the value of, sometime back I told the value of e power minus j pi is minus 1. Similarly, the value of e power minus j pi by 2, this value is always equal to minus j. That is equal to what? Minus j. So this is nothing but what? This is nothing but minus j, this k as it is multiplied by x of k. See, in this case, no, I don't go on expanding the value of x of k. If you want, you can just do it. Okay, if you want, you can just what, do it. But I've not found x of k, right? If you had found x of k, this is what? X of 0, x of 1, x of 2 till x of 8, then you can substitute those values. Okay? So in the exam, check the amount of marks. If this whole of this question has been asked only for 4 marks, 2 marks for part A, this is sufficient, and 2 marks for part B, this is sufficient. If the same question has been asked for 8 marks, then what you must do? You must find x of k, then substitute the values of x of k and get this answer. Is it clear? Yes. So this is the solution of this particular problem. Yeah. If anyone has got any doubt, you can ask me, or else we'll go for the next problem. Students. What happened, students? Are you there?
Yes,
Yes,
ma'am.
ma'am.
Any doubt? Yeah, so far, any doubt?
No, ma'am.
Yeah. Can we proceed further?
Yes,
So
ma'am.
don't worry, now
Ma'am.
do it along with me. For all these problems, the entire neat solution will be given as notes. Okay? And did you people check out the canvas? The entire module 1 theory notes plus the first few problems has been shared. And whatever problems I'll do for today's class and the next Wednesday's class, along with that extra problems from your previous university exam solutions, okay, that also the entire notes will be shared. Nothing to worry. But right now, do it along with me for a better learning. Okay, next is, take down the next problem. Some number, I don't know, is it 5 or 6, I'm not very sure. Take it down. Yeah. Shall I dictate? Ready?
Yes, ma'am.
Yes, ma'am.
Compute the 4-point DFT, compute the 4-point DFT of the given sequence, x of n is equal to 1, 0, 1, 0. Compute the 4-point DFT of sequence x of n, defined like this. Next line, also also find y of n, if y of k is equal to x of k minus 2 index modulo 4. Okay, so again the problem is being asked in two parts. In part A, you are required to find the 4-point DFT of x of n. In part B, you are required to find y of n, provided its DFT y of k is bearing this kind of relationship with x of k. So the first part A solution is up to you people. Okay, do it to me. Okay, again use that linear transformation method. Okay, and you get the answer. What is that? X of k is what? Nothing but wn multiplied by xn. Okay, so use the same matrix method, all of you, and give me the answer. X of 0, x of 1, x of 2, and x of 3. This matrix I don't like. By this point of time, everybody should have got this matrix in your mind. Minus j, minus 1, and plus j, minus 1, 1, and minus 1. See, first row and third row very easy to remember here. All is remember is the second row and the fourth row. That is also easy. There is a trick. If you could just go through it, you'll be able to understand where to write what. Into what? 1, 0, 1, 0. At least now, this time I expect one of the boy to give the answer quickly. I want the values of x of k. What is x of 0, x of 1, x of 2, and x of 3?
X of k is equal to
Yes,
2020.
exactly right. It's 2, 0, 2, 0. And please, as I told you, always denote the first sample value by an arrow mark. Yes, everybody do not copy down. Please verify it. Please verify it. Verify it.
Yes, ma'am.
Yes, fine. So this is your part 1. And part 2, again, what is that? You got to use the property. Now, can anybody say me, by the problem definition, what is that saying? To find what? To find y of n, you're required to find out if what? If y of k is defined as what? Capital X of k minus 2 index modulo 4. Can you people say me which property has been used over here? Which property has been used over here?
Circular frequency shift.
Exactly right. Circular frequency shift. See, unlike the previous 2-3 problems where we saw the time domain sequence was shifted, x of n was shifted, but whereas in this case, its counterpart DFT x of k has been shifted by an interval of 2. When I mean to say x of k has got shifted means the shifting is being visualized in the frequency domain. So what do we find now? Or to find y of n. So how to find y of n? See, we start now the problem. If y of k is nothing but x of k minus 2 index modulo 4. To find y of k, what I must find? I must find its corresponding IDFT value. IDFT of y of k is nothing but what? The IDFT of this circularly shifted sequence in the frequency domain. So here what I do, I apply the complex frequency as a frequency time shift property. Accordingly, IDFT of y of k is what? Y of n. And IDFT of x of k minus 2 index modulo 4 by the frequency time shift property is given by Wn to the power of minus whatever is this value, what is that? L times n into x of n. Please recollect the property statements here. All property statements. And now listen here, the whole class of section A. Wednesday morning when I'm coming, for the first 10 minutes, for the whole class, I'm going to ask any one of the property statement. I'll call out their names. And whichever property I'm going to ask, you people should be able to state it. Only if you're able to state it, you will get attendance, or else no. Is it clear? So learn all the property statements and come for Wednesday's class. So accordingly, therefore, y of n is nothing but what? In this case, the value of capital N is 4, the value of L is 2, it's times n into x of n. Therefore, y of n is nothing but, see, W4 raised to the power of minus 2 is nothing but minus 1. It always cross-check. W4 to the power of minus 2, this term, is nothing but minus 1 raised to the power of n into x of n, All of you know what is x of 0, x of 1, x of 2, and x of 3. Please know that it is not x of k, it is x of n. Accordingly, substitute it and give me the value of y of n. What is y of 0, what is y of 1, y of 2, and y of 3. Please substitute here the values of x of 0, 1, 2, 3, the time domain values. Accordingly, we have vary the value of n also as 0, 1, 2, 3, and get me the values. What happens, students? Substitute this x of 0. Yeah, x of 0 is 1. Minus 1 to the power of 0 is 1. 1 into 1 is 1. What happened all of a sudden?
1 0 1 0.
Yeah, exactly. It's 1 0 1 0. Like this, just by seeing only you people can say, yeah, it's simple values. Okay, what about other students? Finish doing it?
Yes, ma'am.
Yes, ma'am.
Yes, the boys.
Yes, ma'am.
From since morning, only this boy, and once I heard that Elvin's voice. I don't know whether are there really any other boys in the classroom, 5th A or not, virtual classroom. Can I hear anybody else's voice? The other students' voice of 5th
Yes,
year?
ma'am.
1 or 2. Yes. Now, okay, again, a general question to all of you. Shall I do one more problem on circular convolution? Now, be very frank. Or the next class? It's your wish. No force. Yes, Elvin.
Ma'am, we have 10:30.
Okay, but fine then, fine. Okay, I'll stop the class here. In the next class, we'll do a 5 or 6 more sums. Okay, and once for all, I'll be sharing. And today, do one thing. On that canvas, I'll be posting 3 to 4 questions. All of you are supposed to do that and come for the next class. Next class, where I'm going to ask you the property statement, you people must also show, just display the sheets of what you have solved. Is it clear? So by today evening, I'll be posting 4 numericals. Everybody must solve that and come for Wednesday's class along with the property statement. Clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, see you all. Bye. Have a nice day.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay.
Thank you, ma'am.